We've been looking at trigonometry, and we learnt that in every triangle we've got a hypotenuse, then we've got a side that sits directly next to a given angle, so that's the adjacent side, and you've got a side across from the given angle, the opposite side. And then within that we learned that we can actually remember trig ratios if we just remember a little rhyme called SOHCAHTOA. And SOHCAHTOA is simply a reminder that sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. Okay, we also learned some co-functions. So if I were to switch this around and say hypotenuse over opposite, then I would be dealing with cosec. If I switched this cos around and said it was hypotenuse over adjacent, then I would be dealing with sec. And finally, if I switched and said adjacent over opposite, then I would be dealing with cot. Okay, and today we're finally going to put this knowledge to the test. It is going to be very cool. You're going to see it's so useful. But one thing I want to just remind you of before we dive into that is that if ever you deal with cosec and you need to work it out on your calculator, it's easiest to write it as 1 over sine. Sec is easiest to write it as 1 over cos, and cot easiest to write as 1 over tan. Okay, we're going to need that knowledge to solve some right angled triangles. In our last video we looked specifically at trig equations, and we saw that we can be asked to solve for a side if we are given an angle, and that's very straightforward. You just type into your calculator sine of 60 degrees and you get an answer there of 0.87 units. Okay, or alternatively you could be given a side length and asked to determine an unknown angle. And then remember what we did was we said P is equal to, and we said arc sine of 0.5. So on your calculator, remember that is the shift button there. So you're going to say shift and then sine, shift sine of 0.5, and you get an answer there of 30 degrees. Okay, it's important to know this because we are actually going to jump into solving triangles, and we need to understand that when we work out a side length, we just use plain old sine or cos or tan. And when we work out an angle, we need to use arc sine or arc cos or arc tan. So with this knowledge, you are ready to solve triangles, okay? And when it comes to solving triangles, there's a helpful little rhyme that most grade 10s say, and it goes like this. You take the side you want, you divide it by the side you have, and you set that equal to a trig ratio of an angle. Okay, trig ratio simply means sine or cos or tan. Okay, so unknown over known equals to the trig ratio. Alright, it's possible to do this the other way around, but it does make the algebra after the question a little bit more tricky. So try and remember this. When solving triangles, the side I want over the side I have. Let's look at some examples. So here we are asked to solve for the unknown, and the unknown side here is this length x. Okay, so what we want to do is we want to take the side I want, x, over the side I have. Okay, this AB, I don't know the side length, but I do know the side length here of AC. It's 25 meters. Okay, and then that needs to equal a trig ratio of the angle. Okay, so looking at this triangle, I've got 90 degrees here, I've got 15 degrees there, and if I wanted to be very smart, I could actually work out the value here of A, because I know that the inside angles of a triangle do add up to 180 degrees. Okay, but I'm going to just keep it simple, and I'm going to link things to this 15-degree angle here. Okay, so when we first were introduced to trig, we learned how to label triangles. We start by looking for the 90, and then we say the side opposite that is the hypotenuse. Okay, Next up, we said which side is touching the given angle, and that is the adjacent. And then finally, the one that is across the triangle from the given angle, that would be known as the opposite. So if you have a look now at what we did when we said the side I want over the side I have, we took the adjacent side over the hypotenuse. So that is adjacent over hypotenuse. Now I need to refresh my memory. So, ka, toa. Have a look at these three options. Adjacent over hypotenuse is the cos ratio. So to solve this triangle, I would need to say equals cos of 15 degrees. And now it's a simple equation for me to solve. So at the moment, we're dividing by 25. What I want to do to get rid of that is multiply by 25. And what I do on the one side, I do on the other side. So x is equal to 25 times cos 15. And then we pop that into our calculator. We don't need to use the shift button because we were given the angle. So it's just a straightforward calculation there. And we get 24,15. And then have a look at the question to see if the units were given. So in this case, they told us that this measurement is in meters. If not, we would simply write units. So that's how we solve right angle triangles. The unknown over the known, and then you link it to sine, cos, or tan. Let's look at another example. So the side I want is this HJ here, marked as X. Okay, I'm given an angle there of 30 degrees. So let's link all these different sides. Okay, I look for the 90. Opposite from that, that's the hypotenuse. Then I see which side other than the hypotenuse is touching my given angle. That's the adjacent. And then I say across from the 30, what am I looking at? I'm looking at the opposite side. Okay. Then just for my own reference, I'm going to write down here so, ka, toa, because that's going to come in handy when we come to that part of the question. And now I'm going to follow my little rhyme. And my rhyme says the side I want, X, over the side I have. Between those two, I've been given 16 millimeters there. So over 16 is equal to something. Now, how do I know what that something is? Well, I start by filling in what I know. So X, that was H, and O was the 16. So H over O is actually not here in SOHCAHTOA. It's the inverse of sine, hey? The reciprocal there of the sine. Okay, so I've got two options. We learned that then could be cosec. Or what we learned, and what I find to be more helpful, is that because I'm going to put it on my calculator, I'm going to write it as 1 over sine of the angle. Okay, either of those is correct. It's just that this one is going to be much easier to calculate. Okay, so I took the unknown over the known. I saw it kind of looked like sine, but it was upside down. It was the reciprocal, and so that means it's equal to cosec. How else can I write cosec? I can write it as 1 over sine of that given angle. All right, now we're going to multiply both sides by 16. So what that's going to end up looking like is that X is going to equal 16 over sine of 30 degrees. And then we type that into the calculator, 16 over sine 30, and you get an answer there of 32 millimeters. Okay, again, I've gone and I've looked at the sketch. I can see the units there are millimeters. In this example, we've got two unknowns. So the one thing we're looking for is this side length here, X, and then the other thing we're looking for is this missing angle here, Y. All right, so we've got a couple of different things we could do. I usually say it's better to work alphabetically. So if I'm given more than one unknown, I generally start with X and then Y, because X comes first in the alphabet, but you are welcome to use whichever method you prefer. Okay, normally what I would want to do is I want to take the side I want over the side I have, and I've got options here, and then link it to some ratio of the given angle. But the problem is the angle is also unknown. So now I need to think about my other knowledge of right-angled triangles, and that is the theorem of Pythagoras. So Pythagoras says that the hypotenuse squared, let's get our hypotenuse labeled here. Our hypotenuse is this side here, h, and the hypotenuse squared is equal to the sum of the squares on the other two sides. So what that means is that df squared plus de squared must equal ef squared. Okay, and then we always give a reason there. The reason is Pythagoras. Then we substitute in what we know. df is 3. de we don't know. That's just x for now. Equals ef is 5. Okay, so 9 plus x squared equals 25. Then we're going to move this 9 across. So we'll be left with x squared is equal to 16. And then we square root both sides. Remember that whenever you introduce a root, you do it with a plus or a minus. And so x is equal to plus or minus 4. And now we can make a logical conclusion to say, I can't have a negative side length in a triangle. And so that means that x in this instance can only equal 4 centimeters. Okay, and now I've got that. I'm going to pop it onto my sketch, and now I'm ready to work out y. Okay, so what I would normally do when I'm missing a side is I'd say side I want over side I have, but in this instance I'm missing an angle. So my approach is similar, but it's not exactly the same. Okay, let's link things to that angle. So we already saw that we have a hypotenuse there across from the 90 degrees. Then touching this angle is this 3 centimeter side. So we're going to call that adjacent. And the 4 centimeters that we've worked out is the opposite. Okay, I like to look at what I was given in my question. So I was given the 3 centimeters and the 5 centimeters. So I can use any side lengths here, but just in case I made a calculation mistake here, I'm going to be safer going with the values that they've given us. Okay, so I've got adjacent and hypotenuse. And if I remember back to SOHCAHTOA, let's write that down, SOHCAHTOA, adjacent and hypotenuse links to cos. So what I can do then is I can say cos of that angle is equal to, and now I know that cos is adjacent over hypotenuse, so now I can just write in those values. Adjacent is 3, hypotenuse is 5. Okay, and now that missing thing is an angle. That is angle y. So that means when I solve this equation, I need to use the arc cos. So shift cos 3 over 5, and that'll give me an answer in degrees. Shift cos 3 over 5 gives us 53,13 degrees. Okay, so in this case we don't use unknown over known because we actually know both sides. But what we do is we have a look at the sides we have and we see, can they link to sine or to cos or to tan? And then, because it's an angle that's missing, we need to use the arc cos function. Here's one last example for us to try. Solve for the unknown. And the unknown is this theta over here, angle C. So that's what we're missing. Okay, let's have a look at what we have in that triangle. This is a right angle triangle. If they give a 90 degrees on one side, you are welcome to assume that the other side is also 90 degrees. Okay, because 90 plus 90 is 180, and those are angles on a straight line. Okay, so if I want an angle, then I need to look for two sides that I've been given, and I need to see if it links to sine, cos, or tan. Okay, so that's going to be my goal. I'm writing that down there. Okay, But the problem is, at the moment, we've got one side and a missing angle. And that's all we know about this triangle BDC. So what we need to do is we need to think smart and say, I do have some information here in this triangle that may help me. And so what I like to call it is looking for a bridge. We look for a side that could be linking a triangle that has a lot of information to a triangle that doesn't have enough information yet. Okay, so let's have a look in triangle, and we're even going to tell our marker that we're doing that, in triangle ABD. Okay, so we're moving. Let's color code the whole triangle. We're going to work in this yellow triangle here. Okay, we want to link now our sides to this angle. So we've got a hypotenuse across from the 90. We've got, if we look at this 40-degree angle here, we've got the 16 meters is adjacent, and then the one that's missing is opposite. Okay, so what do? We're looking for a side length. So that's when we take the side I want over the side I have. So at the moment, I want that side BD over. The side I have in this yellow triangle is 16 meters. Okay, we have just seen that the side we want is the opposite over the adjacent. So have a look there at Sokotoa, and you'll see opposite over adjacent is tan. Tan of that angle, 40 degrees. Then what we do to get BD on its own, we multiply both sides by the 16. So BD is equal to 16 multiplied by tan 40. 16 tan 40. And we get an answer there of 13,4255941. Okay, we're not going to round off yet because that's actually not what they were asking for. They asked for an angle here. So we can't round off because it's not our final answer. We're going to keep all of those decimal places. And now that we know that, let's write it into our sketch. So this side length here is 13,425 ... Okay, we've got some valuable information there. Now let's move over into this blue triangle. Okay, we want this angle C here. So let's link. This is the hypotenuse. It's across from the 90 degrees. 15 is adjacent. And then the 13 that we've just worked out is opposite again. Okay, so what I'm dealing with now is two sides. One of them is O and one of them is A. So again, I have a look here and I say I can make that equal to tan. So if I say tan of theta, well, tan is opposite O, that's this 13 comma all those decimals, 13,4255941 over the 15 meters. And then, because it's an angle that I need, I'm going to use the arctan. So shift tan of 13,4255941 over 15. And that is going to give me an answer on my calculator there, 41,83 degrees. So there we have it. We were asked to find this unknown angle. We didn't have enough information at first glance, but we could work in this yellow triangle, build a bridge, and then solve for the unknown.